In this experiment, we will be measuring the angle of deviation for various angle of incidence on the prism. With these values, we will be drawing an ID curve. From the graph, it is possible to evaluate what is the angle of prism and also the angle of minimum deviation capital D. Once A and D is obtained, we can find out the refractive index of the material of the prism. ABC is the prism, BC is the base of the prism. If PQ is the incident ray, the angle of incidence being I1, that is, this is the normal, so I1 is the angle of incidence. This ray on entering the prism gets refracted and bends due to difference in refractive index. At this point, it again bends and it emerges out of the prism. Since it emerges from prism to air, it deviates away from the normal here. So this is the path of the ray within the prism. Now, if I extend this incident ray and the final emergent ray back, then this angle, I can call it as angle of deviation for this particular ray. Now, considering this triangle MQR, this external angle can be interpreted as sum of the two other interior angles of this triangle. So, I can write D as this angle plus this angle. Now, from the fact that these are two straight lines and this is I1, then this should also be I1, or this angle is I1 minus R1. Similarly, two straight lines, if I call this as I2, then this will also be I2. So this should be I2 minus R2. So this is I2 minus R2. So I can write D is equal to I1 minus R1 plus I2 minus R2. Now the equation D equals I1 minus R1 plus I2 minus R2 can be rearranged as I1 plus I2 minus R1 plus R2. That is our equation 1. Now consider the quadrilateral AQNRA. That is AQNRA. We know that sum of the angles of all the four angles of this quadrilateral should be 360. But this angle is a right angle, and similarly this angle is also a right angle. So I can interpret that angle A plus angle N should be 180. So from the quadrilateral, I interpret that angle A plus angle N equals 180 degree. Now consider the triangle QNR. QNR. So sum of the angles of a triangle should be 180. So I can write R1 plus R2 plus angle N will be equal to 180. So that is my equation number 3. Now, from equation 2 and 3, I can interpret that angle A equals R1 plus R2 because this is the same, this is the same. So, R1 plus R2 equals A, or now using this relation onto equation number 1, I can say D equals I1 plus I2 minus A. R1 plus R2 is equal to A. So I've used it here, and my final equation is D equals I1 plus I2 minus A. Here I1 is the angle of incidence and actually I2 is the angle of emergence. But in optics, we can think of a ray coming through this way, then it will retrace the same path and emerge it out here. So I can have the idea of calling this angle as the second angle of incidence I2 for the same deviation D. The procedure for this experiment would include setting the prism for a desired angle of incidence and measuring this angle of deviation d. So we will set the prism for various angle of incidence and measure the corresponding angle of deviation d. The next step would be to draw a ID graph. We'll take all the angle of incidence along the x-axis and the corresponding deviation d on the y-axis. So the graph would look something like this. Graph will look like this. So you can see that for a given deviation d, for any given deviation, there are two angle of incidence corresponding to this d. But you can see as we go down, for this particular deviation, there is only one angle of incidence. While for any other angle of deviation, there will be two angle of incidence on this graph point. This angle of minimum deviation, which I would like to call as capital D, D small d equals capital D at this point. This point will correspond to one single angle of incidence, which I would call as I. So at this point, I1 equals I2 equals I. That is, when the deviation D equals minimum deviation capital D, then I1 equals I2 equals I. This relation, we can use it over here. So I'll replace this with capital D and this by 2I. So my equation becomes A is equal to 2I minus D. That is, we can interpret that the angle of prism will be twice the angle of incidence corresponding to angle of minimum deviation or condition of minimum deviation. This relation we will be using to find out the angle of prism once the ID curve is drawn. Now that we have found out what is the angle of minimum deviation, capital D, and the angle of prism A, which is 2I minus D, now we can go for refractive index of the material of the prism. That is, mu is equal to sine A plus D by 2 by sine A by 2. So with this relation, we can calculate refractive index of the material of the prism. The initial adjustments of the telescope and the collimator is done. At the end of the collimator, there is the light source. Now I will view the direct image through the telescope. I will place it on the cross wire, clamp the main screw and adjust the fine adjustment screw to get the image exactly on the cross wire. Now the next step would be to release the vernier table and make the reading on the vernier 0, 180. You will keep it, the vernier 1 in one of the vernier at 0 degree and the other in 180 reading. Now you can use the fine screw to make it exactly 0, 180. While taking reading, make it a point to always use a magnifier glass to observe the coinciding vernier division and check the exact main scale division. Now if we want to set the angle of incidence 40, we should rotate the telescope through an angle theta, which is equal to 180 minus 2y. That is, I is 40, so 2y is 80. 180 minus 2y will give you an angle of 100. Release the telescope and rotate it through an angle 100. So my reading, which was 180, would now become 80 here. The reading has now become 80. Clamp the main screw of the telescope. Now adjust the fine screw so that exactly the reading is 80 in the MSR. Use the magnifier glass to observe the coinciding vernier division and check the exact main scale division. Now, at this position, I can interpret that if this was the direct reading, I have turned through 100 degree, so this should be 80 degree. Now I will mount the prism on the prism table, and you can rotate the prism table, or the correct procedure is to release the vernier table and rotate the vernier table rather than the prism table. So looking through the telescope, I should be able to get the reflected image at this position of the telescope. So looking through the telescope, you can see the reflected image. So clamp the main screw of the telescope and use a fine adjustment to exactly coincide the line spectrum with the crosswire. Now this is 100 degree, this is 80 degree, and we have got the reflected ray on the telescope. So what does that mean? It means that if this is a normal to the reflecting surface of the prism, then this angle is 40 and this angle of reflection is 40. So angle of incidence, which is defined as the incident ray and the normal, this angle is now 40, and angle of reflection, which is defined as the angle between the normal and the reflected ray, is also 40. It is the law of reflection that angle of incidence will always be equal to angle of reflection. So one thing I can be sure, that is, now the angle of incidence is 40 degree. The angle between the telescope and the collimator is 80 degree, and the telescope is positioned at an angle of 100 degree from the direct. Now the angle of incidence is 40 degree. Light is falling here in 40 degree and it passes through the prism and gets refracted here. You will get a refracted image here. One thing to be noted here is often a confusion happens. That is, if at all this incident side was the other one, I'll show it to you. If it was this side, here also you can set the angle of incidence 40, but then you will not get a refracted image on this side because the base of the prism is so positioned that for this angle of incidence 40, you will not get an emergent beam here. So before you do your reading, just with a common sense idea, think of the path of the ray. If you get an angle of incidence 40 on this side, the ray will enter the prism here and it will come out of the prism and you will get a refracted image here. Step is set for angle of incidence 40. Now I will release this telescope and take it to observe the refracted image somewhere here. That's a direct image. Now going to the refracted image. I've got the image on the crosswire. I'll clamp the main screw, use the fine screw to exactly coincide with the crosswire. Looking through the telescope, this is my view. I've got the direct image which is refracted now as the slit, and near to it I have a small thin line of green tint which shows it's a refraction process that has happened, and it is the slight green component from the sodium lamp that is seen here. We have got the refracted image here. So if this is the direct image position, this is the refracted image position, so this would be the angle of deviation D which we will have to measure. So under this position of telescope, let us take the vernier 1 reading and vernier 2 reading. After that, enter it on your observation column. Now release your telescope from this refracted image position, move it to the direct image position, clamp it on the direct image, clamp your main screw, use your fine screw to exactly coincide. If the image is not clear, you can also remove the prism to get your direct image. Take your reading on the vernier 1 and vernier 2 for this direct image. So once again, you can see that we have measured this direct image as the last step. Before that, we measured this deviated angle or the refracted angle, so that this is the angle of deviation for angle of incidence 40 degree. So for angle of incidence 40, we turned it through 100 degree, then noted down the refracted reading, MSR, VSR and total on vernier 1 and vernier 2, then took the direct reading on vernier 1 and vernier 2. So angle of deviation D is the difference between this reading and this reading. So enter it here and find out the deviation D. Now for angle of incidence 45, we will have to turn it through 180 minus 2i. So that is 180 minus 90. So here you will enter as 90 degree. We will turn the telescope through 90 degree and set the prism for angle of incidence 45. Then take the refracted image reading and take the direct image reading, and difference between this reading and this reading will give us the angle of deviation for angle of incidence 45. We will brush up the procedure for setting the angle of incidence 45. So first you take your direct reading, set it on the cross wire, clamp the telescope. Now release the vernier table and make the reading 180 on the vernier. Clamp it, use the fine screw for fine adjustment. So now the telescope has the direct reading and the reading is 180 on the vernier. Now release the telescope, turn it through 180 minus 2i, that is 90 degree, so that your reading on the vernier will be 90 and 270 on the other vernier. So clamp it. Now mount the prism on the prism table. With this position, release the vernier table, looking through the telescope at this 90 degree, get the reflected image, clamp the vernier table here, use the fine screw so that it exactly coincides with the cross wire. Now the angle of incidence, you can say if this is the normal, angle of incidence is 45, angle of reflection is 45. We have set the angle between the collimator and the telescope as 90, so that the angle of incidence equals 45 is ensured. Under this position of prism, we will release the telescope and observe the refracted image here. Now I have got the refracted image, clamp it there, use the fine adjustment screw for exact coincidence. Take your vernier 1 reading, take your vernier 2 reading. So this is the reading of angle of deviation. But don't forget to get the direct image also. So bring it in direct position. If you are not able to see the direct image, you can remove the prism, put it in line with the direct image, clamp it with the main screw, use your fine screw to coincide, and take your vernier 1 reading and vernier 2 reading. enter these direct reading and the refracted reading onto your observation column and find out what is D for angle of incidence 45. Now repeat this for angle of incidence 50, 55, 60 and so on. For every angle of incidence, calculate the angle of deviation in this column. Use these I values on the x-axis to plot the graph and the corresponding D values on the y-axis and you will get a graph like this. Under this minimum deviation condition, we will denote the deviation as capital D and the angle of incidence as I1 equals I2 equals I under this condition. So this D value and I value, we can use it here to find out the angle of prism A. A is equal to 2I minus D. So once A is calculated and D is got from this graph, we can substitute it here sin A plus D by 2 by sin A by 2 so that you can calculate your refractive index of the material of the prism. Now coming to the result, the variation of the angle of deviation with the angle of incidence of a prism has been studied and the ID curve is drawn. Refractive index of the material of the prism is calculated.